Now that we have a basic understanding of where the graphs come from, let's go through and do a couple of examples with some transformations with them as well as a base function. So the first one that we want to draw is just the regular one, the y equals sine of x. So you're going to have to bear with me because of the technology that I'm using. It's not as easy as if we're on paper. But my advice when you go through and graph any kind of trig function is that you go ahead and you make your graph first, okay? But do not put in the tick marks on the x-axis or the y-axis. So I'm going to go through and graph, and I'm going to use a different color for the graph. Excuse me. So we know that a sine function, let's see, sine of 0 radians is 0. So that means then we start right here at 0. Then remember, it starts to increase as the rotation continues to go through the angle. So when I am at pi divided by 6, I'm at 1/2. When I am at pi over 4, I'm at square root of 2 over 2. Pi over 3, I'm at square root of 3 over 2. Pi over 2, I'm at 1. So I'm going to slowly increase until I hit my maximum. Then we're going to come back down, cross the x-axis. Then we're going to come down, hit my minimum, and back up to the x-axis again. So what this does, and after a while, just the first one that I'm doing here today, you can see that this isn't quite as long as this one, and that's why you do it after. You put in all your marks afterwards on the x and the y-axis. As time goes on, you'll get them to be a little bit closer to the same distance, and then we just go ahead and put our marks in after. So I'm going to bring this so it comes down to my low point. And like we said, we know that we hit our maximum at pi over 2. We cross the axis at pi. We hit our minimum at 3 pi over 2. And then we hit back one complete period at 2 pi. And then back here, this would be the equivalent of a negative pi divided by 2. We know that the regular sine function from the previous video, its amplitude is 1, so that means the distance from the midline to here is just going to be 1, and then that means my minimum is negative 1. So again, the idea, what you have to do is you have to graph the curve first, and that's why the nice thing is these are sinusoidal curves, so sine and cosine are going to look the same. You just go ahead, you make a curve, comes up, comes back down to the x-axis, rotates to the bottom, and then comes back up to the x-axis for sine. And for sine, we start at 0, okay? Or in cases where we move things around, we start at the midline. And now the midline for this case is the x-axis. So it's the line that's directly in between the maximum and the minimum. And we know that the amplitude, again, is 1, and our period is 2 pi. All right, so let's graph one now that has some transformations. Okay, so the nice thing is that all of the work that we've done with transformations before, all the stuff is the same. So now if I look here, this negative sign means that it's flipped about the x-axis. The 2 means that it's been stretched. So now if it's been stretched, that means that the amplitude is going to change. So the amplitude is now 2. Okay, so if we stretch it, and it's a lot easier to see, we've been talking a lot about stretch and compression in both directions. It's going to be really easy to see that in our sine and cosine functions. So finally, it'll make a little bit more sense. And then this part here, the plus 3 at the end, well, that means that the entire graph goes up 3. So let's get an axis drawn, and I'll actually just use green for this one at the moment. So I'm going to, best I can with straight lines. Obviously, if you're drawing this on paper, you've got the ability to use graph paper. I mean, rulers rather. So let's see, this whole thing's going to get moved up 3. So then I'm actually going to let my x-axis be way down here. Okay. And here I will have to do my marking on the y-axis first. So it's just rough, here's 1, 2, 3, 4, 5. I'll go all the way up to 6. Okay. And I'll just put a, down here, -1. We'll go halfway up. Here's 3. All right. So now the up 3. So what the up 3 does is the up 3 takes the entire graph and bumps it up 3. So that means the midline, which used to be on the x-axis out here, is now going to be at 3. So I'm going to draw a dashed line. And the reason I do dashed is because it is not part of the graph. It's a guideline for me. And then I know that my amplitude is 2. So that means then instead of just going up 1 and down 1, now I'm going to have to go up 2 from the midline and then down 2 from the midline. So now I'm going to get a different color. So we've got, basically, we start at the midline right here is where we start. And since we have the negative sign in front, remember that a regular sine function starts here, goes up, comes down, back around. All right, so that's what regular y equals sine x looks like. So sine starts at 0, moves upwards, and then crosses, comes down to its lowest point, and then comes back to the x-axis. Well, in this case, since it's negative, that means we're not going to start upward because this has been reflected. We're going to start down. And again, sine always starts at the midline. So now we're going to go down. And the amplitude, which here was 1, is now 2 based on this number. So I'm going to come down, get to a minimum of 2 on the amplitude, which then means I am at 1 on the y-axis. I'm going to cross. Then I'm going to go through, hit another 2 units in the amplitude, and then come back down and cross. And I've got a little bit more room, so I'm going to continue with the graph based on the way that I have it drawn. Put an arrow at the end because this continues. And then I want to continue my graph in this other direction and get up to the maximum here. So now I need to go ahead and label, I've got my y-axis labeled. Now I need to go ahead and label my x-axis. So here we know this is 0. And then I've got to worry about where I hit my minimum. So my minimum, I have to continue down to here. This is my minimum. Then I look here. This is where I cross the midline. So that's my other mark. Where I hit my maximum. Where I cross the midline. Here I'm back at my minimum. And let's look going into the negative x-axis. Here's where I hit my maximum. So we don't have any stretch or compression this way. So therefore, since we don't have any of that, now we're going to go through and just deal with the marks as we would normally have. So now if I look, okay, so I would normally hit my minimum at pi over 2. Then I hit my midline again at pi, maximum at 3 pi over 2, then at 2 pi, and then the next pi over 2 would be a 5 pi over 2. And then back here, I'm now at negative pi over 2. All right, so now we're going to take a look at a graph and try to figure out what the equation is going to be based off of that. So now's a good time to start talking about the different types of things that you should be looking for when trying to determine the equation. So one of the things that we've already talked about is that it's important to figure out what the amplitude is. And remember that the amplitude is the distance from the midline to the max and the midline to the minimum. So then that means we also need to figure out what the midline is. Now the midline is going to be an equation because it's a horizontal line. We're going to have to figure out what the period is. And we're also going to have to figure out if there is a phase shift of some kind. And what I mean by phase shift is whether or not it moves left or right. So let's figure out what the equation for the midline is first. So that means I've got to figure out, all right, so the maximum value is 0, the minimum value is -4, so directly in between is going to be where the midline is. So if I can get this to line up properly, ish, okay, so here is my midline, and the midline is going to be at the equation y equals -2. My amplitude, it goes from -2 to 0 and from -2 to -4. So that means my amplitude is 2. My period, so how long to complete an entire cycle. All right, so I'm going to look back here. Notice I crossed the y-axis at the midline. So then that means we're probably looking at a sine function. Okay, so I'm looking here. That's where I'm going to start. I start down. All right, so if I have a sine function and I start down, then that means it's going to be reflected about the x-axis as well. So let's write that down. So reflect about the x-axis. All right. And then how long does it take to complete an entire cycle? So if I go from here down, I cross the midline again, I hit my maximum, and then I come down and I cross again. So in between here and here is where one complete cycle is. All right, so unfortunately I can't get the x-axis to go through and give it to me in radians, such as pi and 2 pi, and I couldn't get it to do that. But if I look here, it's just beyond 3, so that's pi. And then I end, go through again, come back up, come down, hit the midline again here at 2 pi. So it looks like then my period, everything is done in pi. Okay, phase shift, left, right. No, there is none. Okay, so now what we have to do is we have to come up with the equation for all of this. And I know I'm dealing with a sine function. I know I'm dealing with negative. Okay, so now what I need to figure out is how do I fill in this? Y equals A, parentheses, bx minus c plus d. All right, and when we go through the bx minus c, when we deal with this, we'll talk about the phase shift, and that will be an example in the next video on cosine. I'm just going to wait to do that one until we get into cosine. But right now, A deals with the amplitude and whether or not it's reflected about the axis. So then that means we're going to end up with y is equal to -2. All right, the negative because of the reflection, the 2 because of the amplitude. I know I have cosine, and then I'm going to have something afterwards. But now, if I notice that the period has changed, all right, so my period is going to be the general equation for it. My period is equal to 2 pi divided by whatever the absolute value of b is. So if I had an equation, I would go from there. Well, now, knowing that I have the period is only pi, that means that 2 pi divided by the absolute value of b is equal to just pi. So that means that b will have to be 2. Okay, because basically the other thing that I can say is that this number right here is the number of cycles that happen in 2 pi. It's another way at which to think of it. So if I do it by that, number of cycles that happen in 2 pi, all right, so here's 2 pi out here, 1 cycle, 2 cycles. Okay, so that means then that b is equal to 2. So now I have 2x. There's no phase shift. That means there's no left-right movement. Okay, and then plus d, and d is whatever the midline is. So then that means in this case it's not going to be plus d, but it's actually going to be minus 2. So we got this one, for some reason, is all 2's. All right, so again, let's talk about what each thing does. This negative reflects it about the x-axis. The 2 here is this vertical stretch. Cosine Oh, I have no idea why I wrote cosine, and you probably are sitting there looking at me going, Maine, what are you talking about with cosine? So that is not a cosine function. I have no idea why I wrote cosine, so I apologize. I will fix that right away. This is a sine function. And again, it's a sine function because on the y-axis, I am crossing at the midline, okay? So I'm sorry, that is a sine function. So I have a negative because of the flip about the midline, the 2 because of the stretch this way, the sine because it starts at the midline, the 2 here because that's the number of cycles that I will finish in 2 pi, or you look at the way that we calculated the period, which is here. Either way, however you come up with it. The midline, again, we figured out the midline because it's going to go right through the middle of the graph. So the equation for the midline is y equals -2, which is then represented as a -2 on the back, because it's just like all the other functions, the graph we had has been picked up, dropped down to, and put back on the graph. All right, so sorry for that one small error. Again, this is a sine function, not a cosine function. All right, so hopefully this was helpful, get you a little bit more understanding of the transformations of sine. Thank you very much, and have a great rest of your day.